Okay, dear students, we are going to the chapter-wise concept. The topic is matrices and determinants. Now we are going to the next part, that is the properties of multiplication of matrices. Properties of multiplication of matrices. Now we are going to first property, that is commutative property. Commutative property. Commutative property. Multiplication of matrices is not commutative. Multiplication of matrices is not commutative. Multiplication of matrices is not commutative. That is, AB not equal to BA. That is, AB not equal to BA. That means, if AB is equal to BA, then the matrix multiplication is commutative. But it is AB not equal to BA. Since AB represents the product of two matrices A and B. When it is possible, the product of two matrices is possible when the first matrix, number of columns in the first matrix is equal to number of rows in the second matrix, then the matrix multiplication is possible. Otherwise it is not possible. That's why AB is possible, maybe BA is possible, no need to equal them. That's why definitely in generally AB not equal to BA. That's why commutative properties fail for matrix multiplication. But in some particular case it is okay. That is, we are going to the note point for that. Note point 1, that is, if AB is equal to minus BA, if AB is equal to minus BA, then A and B are said to be, then A comma B are said to be, A comma B are said to be anti-commute. Said to be anti-commute. Now this is the property. Now second property. If A is equal to 3006 and B is equal to 5004, that means observe these two matrices represents diagonal matrices. These two matrices represents diagonal matrices of same order. Then AB is equal to BA is equal to 150024. So AB is equal to BA is possible. AB is equal to BA is possible. AB is equal to BA is possible. That means it is commutative. It is commutative. That means for diagonal matrices of same order of two matrices satisfy the commutative property. That means what we have to observe here? What we have to observe? The multiplication of diagonal matrices of same order will be commutative. Multiplication of diagonal matrices of same order order will will be commutative. Will be commutative. Will be commutative. Diagonal matrices of same order will be commutative. That's why observe. So A into B is the same result, 15, 0, 0, 24. B into A is also same result. That's why except in this case matrix multiplication not satisfy the commutative property. Now we are going to associative property. Associative property. Associative property. Now, matrix multiplication is satisfy the associative property. Matrix multiplication is satisfy the associative property. Associative property. That is, A into BC is equal to AB into C. According to the multiplication of matrices. According to the multiplication of matrices. Now we are going to distributive property. Distributive property. Distributive property. Distributive property. We are going to distributive property. So matrix multiplication is distributive with respect to addition. Matrix multiplication. Matrix multiplication is distributive with respect to addition. With respect to addition. That is A into B plus C is equal to AB plus AC. This is called a left distribution. Now, or A plus B into C is equal to AB plus BC. This is the right distribution. AC plus BC. Sorry, this is AC plus BC. So that is AB plus AC. This is AC plus BC. This is right distribution. Now this is the distribution property. Now we are going to identity property. Identity property. Identity property. If A is a matrix, if A is a matrix of order n by n, of order m by n, and I is identity matrix, I is identity matrix of order n by n, then AI is equal to IA is equal to A. AI is equal to IA is equal to A is called identity property, where I is called multiplicative identity, where I is called multiplicative identity. multiplicative identity. I is called multiplicative identity. Now, inverse property. Inverse property. Inverse property. That is, if A comma B are two matrices, A comma B are two matrices such that AB is equal to BA is equal to I, AB is equal to BA is equal to I, then B is called multiplicative inverse of A. Multiplicative inverse of A. Multiplicative inverse of A. Multiplicative inverse of A. That is, B is equal to A inverse. That is, B is equal to A inverse. That's all. So, these are the properties of matrix multiplication. So, properties of matrix multiplication. That's why matrix multiplication is non-commutative. That means if AB is equal to BA, that is commutative. But generally AB not equal to BA. In particular case, that is for two diagonal matrices of same order, satisfy the commutative property. For that, like example, that is 3, 0, 0, 6, 5, 0, 0, 4. The product of these two, AB, it is 2 by 2, it is 2 by 2, AB. So 15, 24. BA, same, 15, 24. That's why in this case only AB is equal to BA. Now, associative property. The matrix multiplication satisfies the associative property such that A into BC is equal to AB into C. That's a distributive property. A into B plus C is equal to AB plus AC. A plus B into C is equal to AC plus BC. That's all. So, here it is left distributive property, that is the right distributive property. Now this is identity property. Identity property where AI is equal to IA is equal to A. I is called multiplicative identity. Here inverse property. AB is equal to BA is equal to I, where B is called multiplicative inverse of A. That is, it represents A inverse. Actually, this inverse is inversion, matrix inversion. It is different. Okay, that's all. Now these are the properties.